Now we're moving on to the chapter triangles. First of all, we all know what triangles are. We all know a few basic properties of triangle, like the sum of the angles is equal to 180 degrees, and there are various type of triangles like equilateral triangles with all the three sides equal, then isosceles triangles with two sides equal and the angles, opposite angles equal. So now we will use these triangles and we will go on to their similarities. So before we start with the similarities of triangles, there are these two theorems that you need to understand, and we will use these two theorems to solve a few very basic questions. So first of all, the first theorem says, if a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. It means that if there is a triangle ABC, this is the triangle, and we draw a line DE which is parallel to BC, and it intersects side AB and AC on points D and E as it is shown in the figure. So it means that this line DE will divide these lines AB and AC in such a way that AD upon DB will be equal to AE upon EC. Correct? If what is given over here is DE is parallel to BC. If DE is parallel to BC, AD upon DB is equal to AE upon EC. Now the next theorem over here is just the vice versa of this. It says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Now if this line DE divides these lines in the same ratio, that is AD upon DB is equal to AE upon EC, then DE is parallel to BC. In this it is just the opposite. What is given is AD upon DB is equal to AE upon EC, and what comes out of this is that DE is parallel to BC. That is it. So these are the two theorems. Now using these theorems we will pursue a few questions. Now first of all, the very basic question first of all occurs that if DE is parallel to BC, then we need to prove that we already know that AD upon DB is equal to AE upon EC, correct? Now with this I'll just take you to another result using this only. Now if AD upon DB is equal to AE upon EC, I'll take reciprocal of both of these. It will mean that DB upon AD is equal to EC upon AE, correct? Now I am adding 1 in both of these. Now what will happen is DB upon AB plus 1 is equal to EC upon AE plus 1. Okay. Now over here what happens is this is AB, this is DB, sorry, this is AD, not AB. Yes, this is AD. This is DB upon AD plus 1, this is EC upon AE plus 1. Okay, so this is DB plus AD, correct, is equal to, this is AE and this is EC plus AE. Now if you see over here, DB plus AD is equal to AB. So this is AB, this is AD. AB upon AD is equal to, what is this? This is EC plus AE. EC plus AE is equal to AC, correct? AC upon AE. So what do we get from here is AB upon AD, AB upon AD is equal to AC upon AE. Okay, same way, using the same procedure, just not taking the reciprocal, we can also reach another. First of all, from here we also know that if we take the reciprocal of this, AD upon AB will be equal to AE upon AC. Okay, and we already know that AD upon BD is equal to AE upon EC. Okay. Now, if we do not take the reciprocal over here and we continue this question same way, then we will reach another result, that is that instead of AD there will be DB upon AB will be equal to EC upon AC. This is another result which you need to prove by your own. If it is given that DE is parallel to BC, try to do this on your own at home. Okay, so this is what I've already told you. We have AD upon DB is equal to AE upon EC, and what do we have over here is AD upon AB is equal to AE upon AC. This ratio also stands correct. Now we've done the theorems. Now using these theorems we will do a few questions. Okay. Now the first question over here says ABCD is a trapezium. Okay. So ABCD is a trapezium in which we have the side AB parallel to the side DC. So this side AB is parallel to side DC. E and F are points on the non-parallel sides AD and BC. E and F are two points on the non-parallel sides AB, AD and BC. Okay, respectively, such that EF is parallel to AB. Okay, EF is parallel to AB, which is also parallel to DC, correct? Now we have to show that AE upon ED is equal to BF upon FC. Okay, now what do we do first of all? First of all, we convert this trapezium into two triangles. How do we do that? We construct the line AC. This is constructed by me, this is not given in the figure. So we construct the line AC, or we join the points AC, and AC intersects EF at G. Okay. Now we have two triangles. Now we have, first of all, in triangle ADC. In triangle ADC, this is a triangle, right? EF is parallel to DC, correct? EG is parallel to DC, correct? Why? Because EF is parallel to DC, right? So EG over here is parallel to DC. Now if EG is parallel to DC, from this theorem what do we get? AE upon ED is equal to AG upon GC. Am I right? Now let's name this as result number 1. Okay. Now let's move on to the other triangle. Now in triangle ABC, what do we have? We have line GF is parallel to AB. Is that correct? Because EF is parallel to AB, so GF is also parallel to AB, right? Now if GF is parallel to AB, we have AG upon GC is equal to BF upon FC, correct? Is this right? AG upon GC is equal to BF upon FC. Now if this stands, let's name this as result number 2. Okay. Now if we see in result number 1 and result number 2, AG upon GC is common. Okay. Now from from 1 and 2, what do we get? AE upon ED is equal to AG upon GC, which is also equal to BF upon FC. Therefore, AE upon ED is equal to BF upon FC, hence proved. This is what we need to prove. AE upon ED is equal to BF upon FC, and we have proven that.